lab embodies the interface program in many ways and particularly uses multi-scale engineering approaches to help understand, diagnose, and treat heart diseases specifically, as well as to understand biological principles in underlying human athletic performance. Specifically, it has produced multiple computational and ML models for FDA-approved clinical usage. Without further ado, Dr. Philip.
Thank you, Will. So this is a student-run symposium, and it's a student-centered symposium, so I don't have prepared remarks, and I'm not going to say a lot because it's really all about the students, but I did want to just give you first a wee bit of background for those who might not know, and a couple of new updates as well. So the background is this program, I've lost count of the number of symposia we had, but 2026 will mark the 20th anniversary of this program, which started with a grant from the Howard Hughes Medical Institute, which was called the Interfaces Graduate Training Programs, which is how the Interfaces name is attached to this program. It's intended to be interdisciplinary. And at the time, a lot of the programs that were applying for this award and getting them, they were just like trying to create interdisciplinary interactions in their campuses. And at UCSD, we were like, well, we already do that. So our job was not to, create a new program in bioinformatics or something like that. We'd already done all that. Our idea was rather to bring together a lot of the existing already interdisciplinary graduate programs around a theme, which was the theme of multiscale biology. And we now have 11 PhD programs in the specialization, which makes us by far the most interdisciplinary graduate program at UCSD and probably in the whole UC system. So that's how we started. Then the intention of that Howard Hughes program was that the NIH would support these programs, successful programs through NIH, NIBID T32s, and we successfully got one, and then we successfully renewed it, and then we successfully renewed it, and then we've recently just successfully renewed it again. And in fact, not only were we successfully renewing, we actually got a perfect score, which at NIH doesn't happen that often. And I can tell you now, it's a direct reflection of the quality of the students that we graduate and the innovation of the research that you do. Because these things are 500 pages long, and most of those 500 pages are devoted to, us being able to demonstrate how successful how high quality our applicants are and how successful our graduates are. That's really what it all boils down to. Some of the things that were very important and different about this latest renewal is, first of all, that the MPI, the other principal investigator of the training grant, going forward is Professor Rangamani, who recently moved to the pharmacology department from MAE. And she succeeded a group of multiple principal investigators, Dr. Taylor, Dr. Sinowski, and Dr. Ellison, which is like a good way of summarizing just how productive and smart and interdisciplinary she is, because she can replace all of them in one go.
No pressure.
The other difference, actually, you might see on these slides, and I have to sort of commend the student organizers for making these slides. It must have been a lot of work. But you'll notice that the pictures by the names of the program faculty are domain science and technology. And so this program, as a requirement of HHMI and NIBIB, and as a sort of principle of the interdisciplinary program that we wanted to create, is dual mentored with mentors from nominally two different disciplines. Over time, this distinction sort of became less and less kind of useful because, first of all, many of our faculty were interdisciplinary to begin with. They had a training in chemistry and they were appointed in biological sciences, or they had a training in engineering and they were appointed in chemistry, and so forth. So our training faculty for many years have already had an interdisciplinary background. And so sort of saying that one mentor should be, quote, an engineer and another should be, quote, biomedical scientist was an old-fashioned idea from the outset. But then it became even more old-fashioned when we started to do interdisciplinary recruitments that the campus has been doing for about a dozen years now, between different health sciences and general campus departments, which result that a lot of the new training faculty are already jointly appointed between pediatrics and computer science, or bioengineering, or between chemistry and pharmacology. And so this notion of having dual mentorship where your two mentors came from two different disciplines really just became even more meaningless. Meanwhile, though, there's a great opportunity of interdisciplinary science that goes way beyond simply bringing different disciplines together, which comes to bringing together the technologies and approaches that are used in different domain areas. So it turns out that the successful approaches in cancer have not been all the same as the successful approaches in cardiovascular disease or in basic biological sciences. And often we learn, and those approaches tend to get used and reused. And often we can learn a lot by going to experts who've developed technologies in other domain areas. So what we've done now is we still have this dual mentorship, but what we ask the trainees to do, and most of you have probably already done, is to identify a domain science mentor and a technology co-mentor, where the idea is the technology co-mentor could work in a different domain science area, and that technology may not have been as effectively applied to your domain area, and vice versa. And so, of course, as you'll see, most of our faculty have both a technology and a domain science area that they work in. But for different students may have different co-mentors for different reasons. So the hope is not to make the process of identifying co-mentors more difficult, but actually to make it easier and hopefully also more sort of creative and successful. So I think that's all I have to say. Again, I want to thank the student organizers and Kelly Raymond for the work you've done to set up the symposium. And before I hand back to Will, maybe ask Dr. Rangamani to say a few words.
Thanks, Andrew. So I'm very excited to be here. Some of you may know that I've been a faculty member of this program since I came here 10 years ago. And my favorite part of any of these sorts of things is working with students. For the past year, I've been coming to the student seminars very sincerely, and it's been the highlight of my calendar to watch the kinds of research you guys are thinking about, how you're taking questions. And I'm very excited to now work in a more appreciative capacity with all of you. Looking forward to it. I wish this were a program I had when I was in grad school. I think that's how much I love this. So, thank you.
Thanks to the co-directors. Next, we will have Dr. Zainab Jahed, who is an assistant professor here in the Chemical and Nanoengineering Department. She completed her postdoc at Stanford and earned her PhD at UC Berkeley, specializing in mechanical engineering and bioengineering. Dr. Head's research, as you'll see, focuses on creating materials and devices that integrate with cells, the applications in cellular signals.